Hello everyone, in this part 9 of straight lines, we will understand the concept of distance between two parallel lines. Whenever we are saying distance between two parallel lines, this distance will be always perpendicular distance. Another point, for two parallel lines, we know very well, or for two lines, slopes must be equal. So whenever we are taking parallel lines, then in that case, coefficient of x and coefficient of y must be equal. Only different part is constant terms. That is why we are saying the distance between parallel lines ax plus by plus c1 is equals to 0 and ax plus by plus c2 is equals to 0. Now look at this thing in this two equation. Only constants are different. So what will be this distance? D is equals to modulus of c1 minus c2 upon under root a square plus b square. Now how this result is coming? So let's do the proof of this part. Now look at this thing. These two parallel lines, equations are this thing. Now for this parallel line, let us suppose this is intersecting at on the point on the x-axis and that point is P. So for equation number 1, coordinates of P, because this point lies on equation number 1, so coordinates of P, how will we get? By substituting y is equals to 0, because on x-axis y is always equals to 0. So what will be this coordinate? Minus c1 upon a, and this is 0. Now from P, perpendicular distance to the line ax plus by plus c2 is equals to 0 by the formula d is equals to ax1 plus by1 plus c upon under root a square plus b square. On the basis of this, now perpendicular distance from P, the coordinate of this one is minus c1 upon a0 to the line, what is this? Ax plus by plus c2 is equals to 0 is d is equals to modulus of a minus c1 upon a, this is 0 because constant is 0, so plus 0 plus c2 upon under root coefficient of, what is this? X is, it means a square plus b square. So what we are getting? D is equals to modulus of c2 minus c1 upon under root a square plus b square. Now here it is coming c1 minus c2, here c2 minus c1, no problem in that case, because if we will take minus common in modulus, then the result will be same. So if anyhow someone is using by c2 minus c1, then the result will be not effective. Now let's start to do some questions so that the concept will be very clear, and we will do the other questions also. Look at this thing in question number 1. Find the distance between parallel lines. In question number 1 a part, we have two parallel lines 15x plus 8y minus 34 is equals to 0. This is the first equation, and another is 15x plus 8y minus 31 is equals to 0. This is the second equation. So distance between these two parallel lines, distance between, because the coefficients are same, so automatically these two lines are parallel. Distance between equation 1 and equation 2, we know very well by the simple rule, d is equals to c1, what is the c1? Minus 34 minus c2, it means minus 31 upon under root a square 15 square plus 8 square, it means what this become? D is equals to minus 34 plus 31 upon, what is this? Under root 225 plus 64, it means what this become? D is equals to 3 upon 17, and this is units, and this is the answer for this part. Now look at this thing in this B part. Find the distance of the line. Look at this thing. Line equation is y is equals to 4x. It means obviously this line will cross the origin or passes through the origin. From the point P41 measured along the line, making an angle 135 degree with the positive direction of x-axis. So if we will count the figure of this line making an angle of 135, it means line direction should be like that. This is 135 and this P.41 is along this line only. So this is 41. Now 4x minus y is equals to 0. It means this is the equation of this line. Y is equals to 4x. Now we have to find out the distance of the line. It means this to this distance, P distance. So for this, what we will do, first of all, we will calculate the equation of this line. And once we will calculate the equation of this line, we will solve these two equations of lines. We will get this intersect point and then we will apply the distance formula. So first of all, let us suppose this line L1, equation of line L. Now y minus y1, it means what this become 1. M means 10 135 into x minus x1. So what is this x1 here? 4 only. It means y minus 1 is equals to minus 1, x minus 4. It means x plus y, and this is minus minus plus 4. Plus 4 will shift this side. It means this become minus 5 is equals to 0. This is the equation number 1. Now we have y is equals to 4x. This is the equation of another line. So let us suppose this equation number is 2. Now from equation 1 and 2, we are going to get, what is this, from equation 1 and equation 2, solve this thing. So what we will get, x plus 4x minus 5 is equals to 0. It means 5x is equals to 5. It means x is equals to 1. Now from equation 2, what we are going to get, from equation 2, we are going to get y is equals to 4. Therefore, coordinates of m, what will be the coordinates of m? Coordinates of m will be 1 4. So this will be the coordinates of this one. Therefore required distance, here I am doing required distance is equals to, for this required distance, this is mp is equals to under root x2 minus x1 whole square, 4 minus 1 whole square, plus y2 minus y1 whole square, 1 minus 4 whole square. It means mp is equals to under root 9 plus 9. It means what this become, under root 18. It means 18 means 3 root 2 units. And this is the answer for this part. Now let's start to do the solution of question number 1c part. In question number 1c part, find the coordinates of the foot of perpendicular from the point minus 1 3 to the line this. So what is the equation of line? 3x minus 4y minus 16 is equals to 0, and this is the point coordinates minus 1 3. So let us suppose this point is P and this perpendicular length will be, we are considering this point is M, and this is the equation of line which we will consider as AP. We have to find out the coordinates of M. For this, first of all, we will find out the equation of line PM, and then we will find out coordinates of this foot by solving these two equations, for equation of line PM and equation of line AP. So first of all, to find out the equation of line PM, we will say slope of line AB. Let us suppose this is M1. M1 means minus coefficient of x upon coefficient of y. It means minus 3 upon minus 4. What this become? 3 upon 4. Let slope of PM be M2. Now for perpendicular lines, what is the rule? M1 M2 is equals to minus 1. So M1 M2 is equals to minus 1 means what will we have? M2 is equals to minus 4 by 3. Minus 4 by 3. Now equation of PM, y minus y1, it means y minus 3, m minus 4 by 3, x minus x1. By cross multiplication, this become 3y minus 9 is equals to minus 4x. This is minus 4. It implies that this become 4x plus 3y and minus 5 is equals to 0. Let us suppose this is the equation number 1 and this is 3x minus 4y minus 16 is equals to 0. This is the equation number 2. Now to solve this thing, multiply this one by 3 and this one by 4. So we will get what this become 12x plus 9y minus 15 is equals to 0, and this is 12x minus 16y minus 64 is equals to 0. On solving this thing, this is minus, this is plus, this is plus. It means 25y is equals to what this become, first of all, plus 49 is equals to 0. It implies that y is equals to minus 49 upon 25, and then from equation 1 we will get the value of x. It means 4x is equals to 5 minus 3y. It means this become minus 49 upon 25. It means 4x is equals to 125 plus this is 147 upon 25. It means x is equals to 68 upon 25. Therefore we can say coordinates of m, what will be the coordinates of m is 68 upon 25 and minus 49 upon 25, and this is the answer for this part. So on the basis of this explanation, you have to try to solve other questions for practice. Don't forget to give the answer of this question in comment box. Thanks and God bless you.